Morning. Today we're going to be looking at the periodic pattern fill-in notes and the periodic poster. The fill-in notes are due in class, while the poster is going to be due next week because we'll do most of it, like 99% today in class, and the remainder will be next week. In the Fun Resources folder, there's a bunch of periodic tables you can use to help you to fill out the information. If you do not have your hard copy or have lost the hard copy, there's also this one. That's the digital version of the hard copy you were given on the first day of class. And remember, class calendar is where you can always find the assignments. So for our periodic notes, in here there's some videos throughout that help you answer the slides in the notes here. So for a period is a row. A period is the horizontal row going across, and it tells you the number of energy levels. And energy levels are the rings in which are like the electron cloud. So as you go, group 1 has 1 energy level. Group 2 has 2 rings of electrons, so it can hold more electrons. So the farther down you go, the larger they get, the more farther out the electrons are. Then we have groups. Groups are the columns. So here you'll type in the boxes, group 1, group 2, 3, 4, 5, 6, 7, and 8. And on your periodic table, it might say like 13 through 18. For the sake of electron and where they're at, we're going to do 1 through 8 up there. That helps us identify something special. So elements in the same group have similar properties, is going to go in this box here, and valence electrons, V-A-L-E-N-C-E, valence. That's the outside or outermost electron. Because we know our atomic number tells us the total number, but our group, so group 1 would have 1 electron on the outside, 2 would have 2. And for further notes on this, you guys can see this slide here has a video to watch going over groups and periods to explain a little more. Then on slide 5, we'll fill out on our table. This is what your assignment will look like for the periodic poster. So you'll do the top section, the Bohr diagram, and the Lewis structure, leaving notation for next week. And to do it, most of them you'll see you can highlight the boxes. The boxes will look like this. They'll have lines. You have to complete the lines. So it's going to be atomic number, and you might have to click for a second until you get to the right box. So atomic number is on top. Then we have our element symbol, the name, and the mass. Remember, protons and electrons are equal to the atomic number. You do the mass, you round the mass after. Here you put the decimal, but you round it to get the neutrons and subtract the atomic number. And you will do this on every single element on your guys' digital table, the poster. Then this is how you would draw the different energy levels. So here's group 1, hydrogen has 1 energy level. Group 2 has 2. Period 3 has 3 energy levels. And these are all group 1. So they have 1 valence electron. 1 on the outside on the red, 1 on the outside, 1 on the outside. In these diagrams, you start by putting 2 in the first energy level. That's the maximum it can hold. Then the others past that can all hold 8. So if you notice, you don't have to have 8. So this one in the gray has 2 for carbon. Carbon has a total of 6. So 2 and 4 on the outside. That can still hold 4 more, but we stop at 4 because that's how many carbon has. And we're going to fill all of the Bohr diagrams out on our poster. Here for valence electrons and Lewis dot structures, a Lewis dot structure is like a simplified Bohr diagram. The Lewis dot is just going to give you the valence electrons on the outside circle. So you can determine the number of valence electrons in an atom by the group number. So G-R-O-U-P, group number. Lewis dot diagrams help you visualize the number of valence electrons in an atom. V-A-L-E-N-C-E, valence electrons. Those are these on the outside. So notice there's 17 blue dots total, but on the ring on the very outside, that third ring, it has 7 electrons. And you notice that it's kind of paired over here in the dot diagram. So 2, 4, 6, 7. But we put like 1 on each side, 1, 2, 3, 4, and then go back around 5, 6, 7. What patterns in the diagram do you notice? So once you fill out your periodic table, and in class we looked at one of these. what do you notice in this diagram? And you can kind of pause the clip while you fill it out. What do you notice? These are in the same group. These are in the same periods. And you can reference back to slides 2 and 3 that we just did to help you answer that into complete sentences. Next, we have some element classes. So we learned about electrons and where they go. Element classes are another way that the periodic table is organized. And there are notes down here that can help you fill out these three slides for some more information. But alkali metals, that is group 1. You'll notice hydrogen's not included. Hydrogen is a nonmetal, but it is in group 1 because it has 1 valence electron, and period 1 because it has 1 energy level. So alkali metals are never found pure in nature because they're too reactive. reactive, too reactive. Group 1 alkali metals have, so if they're group 1, they're going to have 1 valence electron. And these are all of your alkali metals. Alkaline earth metals are also not found pure in nature because they're also too, T-O-O, reactive. And if they're in group 2, think about how many electrons they'll have on the outside. They're going to have 2 valence electrons. As we continue across the table, the transition metals are the giant brick in the middle. These ones don't have patterns with the groups, so they have different numbers of valence electrons. That's why these are not included in groups 1 through 8, which are in gray. So properties of these: good conductors of electricity and heat. They're strong, shiny, malleable and ductile. You can shape it. You can mold it into something different shapes. And then after, if you look at this like lime green color, these ones here are called other metals. So they're not transition metals. They're just here before the staircase. So these are called other metals. That's aluminum, gallium, lead, bismuth, all in this section. Then if you look at this like funky brown color, this is your staircase on your periodic table. And the staircase is like the thick black line on your guys' version. These are metalloids or semi-metals. They have metals and non-metal properties of both. They're shiny, they can semi-conduct electricity like metals, but they're brittle like non-metals. And this whole section right here is a non-metal section past this. Some of our last groups, so non-metals, hydrogen, it's a gas, that's a non-metal, and then it makes like almost like a 7. Carbon, nitrogen, oxygen, sulfur, selenium, and phosphorus, and hydrogen. So we have 3, 4, 5, 6, 7 total. So those, like lime green right there, those are non-metals. They're typically a gas at room temperature, or they're very brittle. Think of like charcoal you can turn into powder. Graphite comes off as you write with it. And they're poor conductors. Following that, in group 7 on your table, those are halogens. Halogens have, group 7, 7 valence electrons. As you go down, they become slightly less reactive. And these can be found kind of bonded to each other in nature, like chlorine gas, fluorine gas. And then our last one, most special of all, are our noble gases. These ones are so special because they have a full outer shell of 8. No other atom has a full outer shell. And because of that, they all have 8, so put 8 valence electrons, they're in group 8, besides helium, He. And if we look at helium on the table, it has 2 electrons. So its outer shell, yes, is full with 2 because it's smaller. So He, capital H, lowercase e, and 2. These are special because they are only found pure in nature. O-N-L-Y, only found pure in nature. Some of their properties can include they're colorless, they're odorless, so you can't see them, you can't smell them, and they're typically very unreactive because they already have all the electrons they need. It's not really reacting with anything. And our last slide here, so what pattern do you notice about different groups? So if it's in group 1, what do you notice? Group 2, what do you notice? On the way to 8. Give me a sentence describing what you notice about groups. Those are the columns. You can refer back to slide 3. patterns you notice in periods. You can refer back to slide 2 on here. So periods are the rows. What patterns do you notice in the rows? Lastly, do not tell me about patterns and groups here for periods and groups. In what ways can we see the periodic table being organized? So list some ways it's tell me. We can see it being organized in blank, blank, blank. We already learned last unit there's a way it's organized besides periods and groups and element classes. Are there any additional patterns? So go on to Google, search up periodic patterns, and you can say some additional periodic patterns are blank. List 4 or so of the different patterns that you see. Not periods and groups as patterns, but what additional patterns are there? So element classes, is it atomic number? There's a bunch of other ones, and some of them might look like this that they come up with, different patterns on the table. There's lots of different options you can go with. So that complete sentence is here, then go get started on your poster. And if we go over to our poster, I'm going to show you guys some quick shortcuts. We're going to get to coloring them with the key, and you can use another periodic table to help you as long as everything in the same group is the same color. So like lithium, sodium, and potassium, you can pick orange, pink, purple, as long as it's the same color. We're just not doing electron notation. So if I zoom in, I like to do 200. We can zoom into 100. 200 is just easier to type on. So on here, we have like neon. Shortcut I showed yesterday, I've given you guys some of the bigger elements. So what you can do, so if I have silicone over here, you need to look up it on the periodic table. Silicone's atomic number is 14. So we'll type 14. I like to center mine. You don't have to, but I like to. You'll put the name, silicone. And then its atomic mass on the table. So atomic mass of silicone is 28.09. So you put the decimal there, then you click on the lines. If you don't click on the whole line, it'll throw off like your spacing on it, and it gets irritating if that happens for you. So 14 protons, because that's the atomic number, as well as, oops, too much clicking, 14 electrons. And then you do 28, because you round down, because it's 0.09. 28 minus 14, that's going to give you also 14 neutrons. That is not always the case, but here it is. Since I have 14, you can look at any of these. So if I'm going to say, okay, I'm going to copy from sulfur. Sulfur has 16. So you click on one of the dots, and I'm going to zoom in a little more because it makes life easier if you're at 200 when you're clicking on dots. So click on a dot, hold Control on the bottom left of your keypad until you click all of the dots. And you can reuse these over and over again. You just hit Control Copy and Control Paste. But I would do like all of this part first on all of the elements, then do all the board diagrams, then do the Lewis structures. So I have it all highlighted. If you accidentally click the background, you just click it one more time and it goes away. Control C, Control V. Use the arrow pad. So I'm using the arrows. I'm using the left arrow to drag it over to where I want. Makes it way easier with the arrow pad. You can move it up to where you want. So silicone has 14, so now I got to count. 2 on the inside, 1, 2. This one can hold a maximum of 8, so 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10. I need 4 more. 1, 2, 3, 4, 5, 6. That's not what I need, so I need to delete 2 of these. So you always do 2 on the inside first. Don't be putting 14 on the outside. These are not representing nucleus. These are just energy levels that hold electrons. That's all these are representing. Then, with that, you'll use your Lewis structure. Lewis structure is whatever's on the outside ring. So you can never have more than 8. This one is in group 4. So you have to write group 4 up here. You just click on it and write 4. So that means that it has 4 on the outside. So this is correct. So we're going to click on our green. And yours don't have to be green. They can be red or whatever color you're feeling. And we're going to copy and paste. Until I have my 4. If it has 5 valence electrons, it would look like this. If it has 6 valence electrons, it would look like that. if it did. 7, you would add 1